Good morning, it's Mr. McTavish, and I'm going to be going over the line following Lego robot. This is a tricky challenge, so I'm hoping to help clear up some questions about it. So first and foremost, we have to define the problem. What are we trying to do? So for this challenge, we're creating a program where the robot would follow the line. If the touch sensor is pressed, example, it hits a wall, the robot would stop, back up for 3 motor rotations, turn, and then continue following the line. And the rest of it is about this, how to hand it in. So here is the situation. You've got a wall, there's 3 states. So the first state is the robot is hitting the wall, and that's a priority. What I mean by that is if it's hitting the wall, it needs to stop everything that it's doing and do the steps that we've given it. The second state is it's on the black line, and the third situation is it's not on the black line. So we've defined 3 separate states for this. So the first thing is, how do we check if the wall is hit? When you're looking in the make code for the Lego, you'll see on the left there's different types of bricks, and the blue logic bricks are set up, and in the blue logic bricks there's an if statement. So this is a great thing. If this situation is true, then you're going to do a series of steps. So that's what we're looking for. The other thing is that there are pink blocks and those are bricks, and these deal with different sensors. So one of the sensors is the touch sensor, and you'll notice that the shape of the touch one is pressed matches the shape of our true. So this returns a true or false. True if it's pressed, false if it's not. So we can drag that shape into that true statement to check for it. Now, we can check now if the wall is hit. So I've highlighted there's 3 separate things that we need to do if the wall is hit. In yellow, we got to stop the robot. In green, we need to back up 3 motor rotations. And then in blue, we need to turn. So breaking down the problem, and this is a really important concept with robotics and programming and stuff. All it is it's problem solving, and robotics is using mechanical tools to solve problems, and programming is using software to solve problems. And the key thing is that having a big problem is hard to solve. Breaking a big problem into smaller problems is much easier to solve. So for example, the robot would stop. Well, if you look at the bricks, they're green motor bricks. And if you look through those bricks, you're going to find one that says stop all motors. Perfect, that's going to stop our robot. Now for the backup, the tank motors B and C, that allows you to control a robot like a tank. And so B and C, B would be on the left-hand side, C would be on the right-hand side. And to back it up, we can change the percentages. So instead of going 50% forward, we could set that to negative 50%, which would move our robot backwards. The other thing is there's a little plus sign, and that plus sign gives you more options. So when you're picking those options, you can look at, and in this case, hey, when I have tank motors, one of the options is how long do I want to do this? Well, I can set the number of rotations, and that fits exactly with what we're trying to do. The third thing is turning. And with the turning, there's a steer motors block. Well, with the steer motors block, I can set a turn ratio. So let's say 180 degrees. And I can also change what I'm looking for. Am I going to do this by rotations, by degrees, seconds, milliseconds? Now, in our example, we're just worried about testing the logic. In the real world, we would load this up to a robot, and let's say we set it for milliseconds. So we would try it for 1,000 milliseconds, which is 1 second, and see, oh, that only turned part way, so maybe I can change it to 3,000 because 3 seconds looks like it would do it. And I would just fine tune through trial and error how to get it. So in my example, I've put it for 2,000. So here is our our forever block. So when our robot powers on, once it's done its setup, it goes into this block, and it's just going to continue to do this forever. So anytime that button is pressed, it stops the motors, it backs them up, and it turns. So that's the key state one. You've got that solved. Now our second state is the robot's on the line. So what do we want to happen? When it's on the line, we want it to veer left. So we want it to go forward, but we want it, as it's going forward, to turn to the left. Okay? And the reason we want to do that is because if it's not on the line, we want to turn it to the right. So we're constantly going forward. We're not doing a sharp turn. We're going back and forth, and that's every time we go off the line, we are just slightly turning. If you've ever paddled a canoe does not go straight. Every time, if you're solo paddling a canoe, every time you put your paddle in, the canoe is actually turning away from your paddle. And a good canoeist will take a paddle and do a J stroke, and so they'll turn the canoe to the left away from their paddle, and then they'll do the J stroke, which will turn it towards their paddle to the right, and basically you're doing small turns and you get going in the right direction. You're following the line. So that's the steps. So our if statement has if the wall is touched. Well, we need a few more options. So there's a plus sign again. So with the plus sign, when we press that, now we get 3 options. So if the wall is touched, do this. Else, if. So the wall is not being touched. So now we can decide, am I on the line or not? If I am, I want to do this. And then obviously, if we're not on the line, then I would do that. So we've broken our problem down into 3 separate stages. Now, I'm not going to give you everything, but I am going to give you some tips. So first off, when I'm trying to decide if I'm on the line, I need to do a comparison. Well, in the logic blocks, there's a comparison. So if this number is less than this number, so I can use that. In the sensor blocks, we have a color sensor. Now, the color sensor has some different options. We can check the reflected light. So this will give us a number. 0, our sensor is over the color black, and we're not getting any light reflected. 100, the sensor is over a white, and it's reflecting back 100% of the light. So I can use my color sensor and use that in my logic block, and I'm going to change my second value. So instead of 0, maybe 50%. So if it's less than 50%, I know I'm on the line. The third brick is the tank motors. Now, when I put on the tank motors, it puts my motors at 50% speed. Well, I can take B as my left motor. So what I can do is I can reduce this so that way my right motor is overpowering it. So I'm going to tend to go towards the left. So if I switch this to maybe 15% and switch this to 20%, now I'm going to veer towards the left. My third state, the robot is not on the line. Well, that's where the else statement comes into play. So if I go back to my if statement, here's where I check, am I on black? Is my reflected light less than 50? Then I'm going to run the tank motors and veer to the left. Else, I can run the tank motors and veer to the right. So those are my 3 states. And I hope that helps. Hope it helps clarify. Don't worry, do your best. The whole goal with this is trying to get people to break down problems and try to put them into smaller problems. So if you get part of it, fantastic. But do your best, and let's see what we can come up with.